Test one. What's up, everybody? This is Matt Brown with another IoT hacking video. Yet again, we have our Hikvision security camera, but today we have finally achieved a successful firmware modification that has given us a root shell via our BGA reballing on this device. We talked about it in the last video, how we were able to lift that BGA flash chip off, perform a firmware modification, write some new firmware onto it, and then put new solder balls on, put it back on. We're not going to be redoing that in this video, but obviously our firmware mod failed to achieve that root shell that we wanted to break us out of the jail that they put us in, where you can only execute certain commands. So I'm going to walk you through my firmware modification that succeeded this time. Let's go to our computer, and first let's actually just go look at that restricted shell again, because this kind of guided my process. I will say that I've gotten a lot better at doing the BGA reball. In our previous video, I was succeeded 1 out of 3 times, and today I think I nailed it 6 out of 6 times, so I'm getting a little bit better. But as you can see here, if I want to type a command, you know, like ls, it'll say, hey, that's not supported, try the help command. And then it prints out for us a set of commands that it has blessed, that it says these are the only commands that you are allowed to run, right? And some of these obviously down here, like top, ping6, ps, like some of these commands are obviously one-to-one pass-throughs to some kind of common Linux command that we're all familiar with. And then there's all these custom commands that we're not exactly sure what they do, but they're clearly specifically for the camera, right? These are not general open source programs. So that's just something to notice. And then if we go up enough, we can do that later. But we saw in the last video that this shell is called the protect shell, and it's a Hikvision thing that they have developed to, you know, kind of whitelist certain commands that you can execute with root privileges. All these commands do run with root privileges, which is important because if we can change any of the behavior of these commands, then it's going to execute as root, and that can allow us to get out of the jail. If we can get out of the jail, then we're getting out with root privileges, which is good. So I'm going to discuss how I went back kind of to the drawing table and looked at the firmware file again, instead of going the U-boot route, which we did last time, because I've completely abandoned that and to get our firmware mod. So I went back and I looked at our firmware image. So this userdata.bin file is the original unmodified firmware file, and so I'm just going to run binwalk on it without any flags or anything like that, and we're gonna get its output. Remember, it's a 7.3 gig file, so it takes a little bit to run. It returns tons of different results, but the results I were interested in is all of these ext file systems, right? So if you're familiar with Linux, ext or ext4 is a very common file system type. And so this is something I was really interested in. And so binwalk has, if I just type binwalk here, you can see it has this -y flag where we can tell it to only look for a certain type of signature. So we can do binwalk -y ext. There's actually a bug with the tool that you have to not put a space between there. So we're going to do that, and we're going to run that again. And here we can see we only get a printout of the ext file systems. And this is really useful because each one of these file system, each one of these headers for these different sections of the firmware, it's parsing all this information, and most importantly, it's parsing the size of the partition. And so here we can see, of course, the offset in decimal, so where in that firmware file the ext file system starts, and then we have a length value here with the size. And we have 1, 2, 3, we have 9 different partitions that it's finding inside of this firmware file. So what I did, let me go pop open a new shell here, and we'll just look at my notes here. We're not going to reparse all of this because these DD commands do take a while to run because I'm very inefficiently doing them. I'm setting the block size to 1 byte. And so it's basically doing a 1 byte at a time copy, which is not efficient, but it's just what we want to do in this case. So I created, based on this information up here from binwalk, right? So for example, to parse this first partition, I started with an offset of this decimal value. So you can see here, my first DD command. So the in file is that original user data.bin file. Our out file is going to be part1, partition1.bin. Again, we're setting the block size to 1, and that means that this is going to be that many bytes, not that many blocks of some value greater than 1 byte. So here we say skip, and we skip the offset. And then the count corresponds to this size value. And that's how I created this set of 9 DD commands, which parsed out each one of those ext4 partitions and left us with all these files. So let's go down here and let's run the file command on part. And there you can see that, okay, I've got a bunch of directories with the same name. That's okay. But you can see these are all ext4 file systems. So it seems that we've carved these out correctly, which is super helpful. So then what I did, of course, is I started mounting them. So the cool thing in Linux is that you can actually mount files, like file binary representations of a file system as, like you can mount those onto a directory, right? So I have this file, part1.bin, which is a ext4 file system. So I can just run sudo mount and run the file, and then I can mount it on this empty directory part1, and then I can go look inside of part1. And here we see a bunch of interesting files, right? Because my high-level goal is to find something that I can modify to get code execution on this device when I perform my firmware modification. So looking around in here, some things stand out, and those are all the shell scripts, right? So we see cellular.sh, this something, blah, 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 uncompress sh, init container, which is really interesting because to my knowledge, this is the first IoT device I've ever seen that runs containers using LXC, I believe. So that's kind of fascinating. And then init run, and that just sounds cool because that sounds like a script that's going to do a bunch of initial device setup, which is exactly what it does. And so, yeah, there's some other shell scripts here, as you can see. But this script, it sounds like it runs on boot every time. Again, it does, obviously. So that's what we're going to go ahead and take a look at. We're going to go take a look at this shell script, and there's a bunch of different stuff that it's doing in the setup process. But one thing that I found really interesting here towards the bottom of the script is a bunch of symlinks being set up. And the reason why this is very interesting is because all of these symlink names a lot of them correspond to the commands that we are allowed to execute over in our protect shell, right? So some of them don't cross over, but let's just, look at print part. So here we see that the binary bin da info is being linked, or we're creating a symlink print part, and we're pointing it to that binary, right? So we go over in our shell here and print part. Okay, cool. That does some kind of printing out of, partition information on the camera. Cool. So that is one of our commands that is allowed. So if we can manipulate that, if we can change what that's pointing to, then we can potentially use this to get code execution, right? Because we are allowed to run the print part command from the protected shell. So let's go back over here. And so what I did is I did not do all of this the first time. So the first thing I actually tried to do, which was incredibly, I don't know why I was thinking about this. So the first thing I did is I came in here and I picked one of these commands. Let's just do it here to this print part command. This isn't actually the one I changed, but I'm like, oh, cool. I want it to point to bin. The first thing I did was bin ash because I did a bunch of Googling and everyone's like, oh, you want to get back to the ASH shell. And people had all these, this advice on these forums, and maybe that applied to an old version of the camera, but it doesn't seem to anymore. But so I tried this, I tried this, and this, when I did this version of it, right? When I tried to symlink one of these commands that's blessed, that's allow to bin/bin/sh, I got an error, and it was kind of a moment where I'm like, oh, duh, that doesn't work, because bin/sh is really pointing to BusyBox. And if you're familiar with BusyBox, the way BusyBox usually works is that all of the different programs like ls, cd, all these different programs will be, you'll have like /bin/ls on the file system, but it won't be a binary. It will be a symlink to the BusyBox binary. And then BusyBox is intelligent enough, so the thing the BusyBox binary does is it looks to see what the name is, right? If it was executed directly or if it was executed via a symlink, and then it will say, it used the bin ls, like the ls symlink, and so I'm going to run the code for ls, for example. So obviously, the print part command doesn't exist in BusyBox, and so it gave me this notorious error, applet not found, which is a weird way of saying that like a program doesn't exist, but that's distinct to BusyBox. That's a very distinct BusyBox error when a command is not built into BusyBox. And so that told me right away, that was like a, like hit the head moment, like, oh yeah, I can't do that. So then I tried, and each time I attempt this, I have to go over there and I have to, desolder the chip and do the whole cycle. So, and then I tried this, and SH already exists. It's like, oh yeah, So I tried a bunch of different stuff. So let's undo all that. And then I did this finally, and I got it to work. So the first thing I did to be like, okay, like I'm like what I'm doing is I can absolutely confirm that I am getting code execution inside of this script, right? By just echoing something out, right? It's like, okay, cool. I got this to print out in the boot log here. That's my Windows machine. So like if I search here, I can say Matt Brown. Come on, man. That's really funny. I must not have like scroll back on all the way. Okay, we got a scroll back problem, but it prints out. You just trust me. All right. So I got that to print out. I'm like, cool. Like I'm confirming that I'm not crazy, that this shell script, I can modify it via my firmware mod, and I'm like it's actually getting executed. And so then I just wanted to like understand what some of these directories were, right? Right. So catting out etc password was super helpful, because that showed me that I could have, and this is another way I could have done this, is I could have just run change shell, because as it turns out, the root or admin user, their shell is /bin/psh, which is that protect shell, and that it's that more limited jailed shell. So, but what I decided to do is kind of a little sneaky thing here. So what I'm going to do here, this is our sweet exploit. Okay, so I'm going to echo, shebang, bin sh, and then as the first line into bin shell please, okay? And then I'm going to put this little line, which if you understand, bash, right, it's going to run the full shell here, bin sh, which is the non-protected shell, -c is going to run a command, and then $1 is whatever is user input, right? It's the first, command line argument. And so that gets appended, so it's a 2-line little shell script file, and then we're going to mark it as executable, and then, this is the key thing, we're going to link task show. So task show is just another one of these programs here. Let's forget about that. Right here. So it is one of the commands that is allowed in the protect shell. And then I'm symlinking it to /bin/shell please. So obviously I then did like the 30-minute thing where I take the chip off, do the firmware write. You can go back to my previous video. I'll link it in the description so you can watch the whole BGA reballing process. So once we do that, we have this task show command. Why do I keep going to my RDP box? All right, so let's make this bigger. Task show, and then I'm space quote. It's printing out a bunch of stuff, which is lame. Oh gosh. Task show ls-la, and we get code execution, which is awesome. Okay, and so what we can do is, because if I just type the ls command here, it'll say, hey, that's not supported, right? So I've effectively proved there and then that I have escaped the shell. If I want to get a permanently escaped shell, I can just do task show /bin/sh. And here you can see that it tells me that I have actually entered ASH, so the standard BusyBox shell, and I can do things like run the cat command, which I wasn't able to do before with that protect shell. There you can see the admin user here, which is UID 0, so it is effectively the root user, and yeah, so there's that protect shell that we are no longer jailed by. We escaped. So yeah, that was pretty cool. Another thing that was helpful in my debug process here, as you can see, I got these errors kind of streaming through here. So I did go ahead and set up a user account here. So I'm going to log in to the camera. There you go. And then under maintenance and security, device debugging, you can actually enable SSH here, which is helpful. Save. And then you don't just have like the scrolling nature of this. Let's run ifconfig. Here we go. Let's run SSH. I believe the user is admin. There we go. Oh my gosh. All right, so off screen, we are going to delete that. Not going to show you guys inside my known hosts file. There we go, and my pass1234 super secure password. So again, we're presented with the protect shell, right? We can't do things like ls, we can't run cat, not supported, right? But now we have task show that we can run any command we want, including to escape out of that shell, which is pretty awesome. We can see all the stuff that's mounted, and we can fully do whatever we want to this device now, which is pretty sweet. So that is the full detail of the firmware mod. Now I'm going to kind of shift gears into saying thank you to some people that made comments, and to give a couple of updates on how I improved my process on doing the BGA reballing, because there were some comments actually on a YouTube video which are helpful. It's crazy. It happens sometimes. So I'm gonna go over here to the desk and just kind of show you some things. First, this is a comment that is not unique to my latest videos. You guys have been complaining about this for a long time. I have upgraded my Q-tip game. So these are like sponge Q-tips. They're not the hairy ones where the hairs get all over, you know, all over crap when you're trying to, you know, clean up flux or whatever. They don't get stuck to chips. And so that has been a big upgrade. The other thing, so let me go look at the other side. We're just gonna unplug this. We're done with the shell for now. So the BGA chip is obviously on the other side on this device. So get our UART off. We'll flip the device over and just give a couple of pointers that I have learned increase my chances of success by a lot. So here we've got our good old BGA chip that I have been taking on and off of this thing all day long. And so let's actually, I'm not gonna do it now, but yeah, you saw in the previous video. So one thing that one of you guys suggested, we'll actually zoom out. So when my chip kind of floated off to the side in that previous video, right, and caused a bunch of problems, one of the things that somebody pointed out is that I was like angling my air, you know, I was putting my air at an angle, right? So here's my, you know, hot air gun. So it was like this instead of like straight up and down like this. And so that was somewhat for you all's benefit because I was doing it under the microscope. I found that I do it way better when I'm not under the microscope to do the reflow on this. And so I think in the future, since I do have the zoom lens on this camera, I'll be able to give you guys a decent picture while I do the reflow, and I can be more vertical up and down with my hot air, and I won't be like pushing the chip off to one side. The other thing is to do with this, and that's basically just when I apply my flux, right? I talked about how you really want a very, very thin layer of flux on there because otherwise it's like, you know, your chip kind of hydroplanes across and it almost assists in the chip getting where it should not be. And so what I do now is I put a little bit of flux down and then I wipe it across and I make it a very thin layer with these new Q-tips. So those are just a couple of quick BGA tips that came from you, the viewer, which is really awesome. I'm getting better. I would say the biggest thing is to keep practicing this because as I did this today over and over and over again, I got consistent with it, right? 6 out of 6 attempts successful, which is pretty good. So thank you for watching this video. Please like, comment, and subscribe. Let me know what you think about this video series or if there's anything cool that you suggest we do with a Hikvision camera now that we have a full unrestricted root shell on it. Thank you and have a good day.